Rational functions and their horizontal asymptotes. There are two cases when horizontal asymptotes occur. One of those cases is when the degree of the numerator is less than the degree of the denominator. If this happens, your horizontal asymptote will always be y equals 0. There's a mathematical reason why this is the case, but for the purposes of this video, we're just going to assume that you either know or you don't want to know what these reasons are. So if your degree here is 1 less than your degree here, or more, then your horizontal asymptote is y equals 0. The second case is if these degrees are the same. See how this degree is 2 and this degree is 2? If these degrees are the same, then your horizontal asymptote is y equals the fraction created by the leading coefficients. So for this particular function, your horizontal asymptote will be 2. So let's review. Two cases. If the degree of the numerator is less than the degree of the denominator, 1 is less than 2, your horizontal asymptote is y equals 0. If your degrees are the same, your horizontal asymptote is the fraction created by the leading coefficients. So here are just some rules that you can try to remember. That's pretty much what I just said. Points 1 and 2. If the numerator's degree is less than the denominator's degree, the horizontal line y equals 0 is the horizontal asymptote. If the degrees are the same, the horizontal line y equals the fraction created by those leading coefficients is the horizontal asymptote. We do have a couple more cases. If the degree of the numerator is 1 more than the degree of the denominator, you're going to have what's called an oblique asymptote, a straight line oblique asymptote. But if the degree of the numerator is more than 1 more than the degree of the denominator, there is no straight line, horizontal or oblique asymptote. Okay, we'll try to get more into depth in steps 3 and 4 in the next video. Find all vertical and horizontal asymptotes, and are there any oblique asymptotes? Well, remember to find vertical asymptotes, you need to completely simplify this expression. So we have x plus 1, that's already completely factored. In the denominator, we can factor that one. Believe this is right. X squared, 5 minus 3 is 2, 15. So it doesn't look like anything can be reduced. So your vertical asymptotes happen everywhere the denominator is 0. X minus 3 equals 0, x plus 5 equals 0, which means x equals 3 is a vertical asymptote, and x equals negative 5 is a vertical asymptote. Horizontal asymptotes, remember you look at the degrees. The degree here is 1. The degree here is 2. The degree of the numerator is 1 less than the degree of the denominator. That means y equals 0 is your horizontal asymptote. If you were to try to graph this one, you would have 1, 2, 3. You would have a vertical asymptote here. You would have a vertical asymptote here. And along the x-axis, you would have a horizontal asymptote. Are there any oblique asymptotes? Well, that happens when this degree is 1 more than this degree, and that's not the case. So oblique asymptotes, there are none. Just trying to really quickly sketch this graph, I believe it looks something like this. It's really difficult to read this one on the calculator, so we should go through a process of graphing, but we'll learn that one a little bit later. I believe it looks something like that.